This is the third video of my advanced hardware course. In this video, I'm going to introduce how I use VHDL to make the inverse of simple function and how I simulate it to make sure it's functional correct. Here I change my project part to NextX4 because when I use Basis 3 to do the implementation, it told me that it does not have that much I/O port, but when I use NextX4 it can be implemented, it can run implementation successful. Let's first go through the VHDL code. At the beginning is the same as the simple function. We have clear, clock, the in and the out as our input and output value. And in the architecture, we design the signal as the same as the like ABX or A-rod, B-rod in the simple function. And here is the difference. The begin, we need to first calculate value B, and B is equal to B minus S2 times I plus 1, and S is from the S key in Rome. After the minus, we have to do the right rotate, and the amount should be the last 5 digits of A. And after the right rotation, we need to do XOR with A. That we got our B, the B. And when we got a new B, we need to calculate A, and A is equal to A minus X 2 times I, and with the right rotate with the last 5 digits of B, and B is the new B, we just get it, and XOR with B, XOR, then we get our A, and that's a new value in the inverse function. Here's the process, and the first is to give the first 32 digit, the high 32 digit to A rack, and the lower 32 digit to B rack. And the counter is also different because we need to count down from 12 to 1, and when it's count to 1, we need to reset it to 12. Okay, that's the VHDL code part. Let's turn to the simulation part. As you can see, when I set my clear to 1, it starts to run, and the value I give here to the input to the inverse function of inverse of simple function, its value is A2B568 BAC 7 EDC2C1. So it's the 12th condition of the simple function. So in this simple function, I give input of 16,0, and by the input of 16,0, the 12th condition of the input the simple function is this A to B value. So I give the 12th condition, the last condition of the simple function, to the inverse. So the inverse input value should be this. And as you can see in the second round, when it has finished the inverse part, in the second round there's countdown from the second 12 to 1, and the initial condition is 16,0. So we have successfully done the inverse part of the simple function in my design. That's all. Thank you.